All right, we are recording. Please stand. And let us pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Remember, O most gracious Virgin Mary, that never was it known that anyone who fled to thy protection, implored thy help, or sought thine intercession, was left unaided. Inspired by this confidence, I fly unto thee, O Virgin of Virgins, my mother. To thee do I come, before thee I stand, sinful and sorrowful. O Mother of the Word incarnate, despise not my petitions, but in thy mercy hear and answer me. Amen. In the name of the Father, and the Son, and of the Holy Spirit. Please take out your 4 C's and Charlie, last 2 problems, and 4 D's. See what you have. Go ahead and take that out in a second. Take it in. I didn't know.
All right, let's take this.
Sometimes I can't remember myself.
No idea. We'll run through them. I'm being a little bit on the merciful side for 1 through 4. There's a, I'll explain more when we get into it.
Oh, that's sad. We have to figure out where to put it. I need it still.
Okay. Grab your favorite red writing utensil. For problems 1 through 4, I'll do those on the board in a little bit. Move this over so people on the video can actually see the human being talking. And here we go. We're skipping back to homework 4C, numbers 31 and 33. Let's see what we have. Whoops. The right page. So, looking at 31, part A, function is even. 31B, odd. 31C, neither. 31D, even. 31E, neither. 31F, odd. And it repeats. Number 33, part A, what kind of symmetry does the graph of an even function have? Y-axis symmetry. I think we might have done these in class. Part B, what kind of symmetry does an odd function have? Origin symmetry. Origin symmetry. And it repeats on 31 and 33. Okay. Now, in the next section, number 1. I'll read out the answers and then we'll explain as we go. Number 1, does it appear to be periodic? The answer is yes. Periodic means it repeats. What is its amplitude? I didn't even tell you what amplitude was, did I? Sorry. I'll give you the amplitude. It's actually pretty easy, but it's nice if I actually tell you what it is. Just write down the answer. The amplitude is 1. And find f of 1,000 and f of negative 1,000. F of 1,000 is negative 1. F of negative 1,000 is positive 1. Again, I'll explain later. Number 2, is it periodic? Yes, it is. The amplitude is 0.5. That's a mystery right now, again, because I paused and forgot to tell you about it. And what is f of 1,000? it's 0. F of negative 1,000, 0. Number 3, is it periodic? Yes. So I forgot. You're supposed to give the period too, which I didn't tell you about either. I'm really doing well this week. All right. I'm not going to test you on that well, probably not. Next, it's actually a teaser for next chapter, but all right. For number 3, the amplitude is 1/2. F of 1,000 is 2, and F of negative 1,000 is 3. For 4, that is not periodic. It has the same sort of shape, but it doesn't repeat the same values over and over and over. It keeps getting bigger and bigger and bigger. So you don't have to tell any of the other stuff. Everybody got this? All right, number 5a, 2f of x should be taking that graph and making it twice as tall. So the values that are at 0 should stay at 0, and the peaks that are at a height of 1 should be at a height of 2. So you have a bunch of little mountains that are 2 units high instead of 1. Everything else should be the same. Number 5c, you didn't have to do 5b. 5c, f of negative 2x, that does 2 things. Number 1, it flips it left-right over the y-axis, which by the way does nothing. It stays identical. And it makes it twice as narrow. It would have made it twice as wide, but it does the opposite of what you expect. So it's kind of like taking an accordion and crushing it. It's going to get half as wide each time. Like, do you see the peak where it goes from 0 and then 1, 1, and then 2, 0? Like on the right, it makes that little mountain going from 0 to 2. That should be half as wide. Let me just draw that. It's really hard to describe. Here's the drawing right now. Here's what the new one should be. Everything should be crushed so it's half as wide. That's the new one. So all the mountains should be half as wide. Instead of being 2 units wide, they're 1 unit wide. And instead of the peak being 1 space over, the peak is 1/2 space over. Does that make sense? Basically take all the x values and cut them in half. So this is 0, 0, that stays put. 1, 1 turns into 1/2, 1. 2, 0 turns into 1, 0, and so on. Don't touch the y values, but the x values get cut in half. Okay. That was number 5c. 5e, all of the mountains move 1/2 space to the right. So the starting point is no longer 0, 0, it's 0, 1/2. It's the exact same height, exact same width, but everything is 1/2 space to the right. Good. Any repeats on number 5? Alrighty, number 7. Sketch the graph of the following. I'm just going to sketch these. 7ACE. This is a little backward. Y plus 2 is equal to absolute value of x. First of all, can anybody tell me what shape that's kind of reminding people of? What sort of graph would you expect? What shape? We went through 6 or 7 parent graphs. This is one of them. What basic shape? Yeah. It's a V graph. There's something weird here. There's a y plus 2. It's in the wrong place. It's supposed to be y equals by itself. That should give you a better estimate of what should really happen. This is the V graph lowered 2 spaces. So it should look like this. Normally the V graph starts at 0, 0. It goes up. Over 1, up 1. Over 2, up 2. Just move it down 2 spaces. Over 1, up 1. Over 2, up 2. And there's your new graph. This was a little bit of a curveball. If y is not by itself, make sure it is by itself, because y equals is the universal universal code for ungraphing it. They did that with C as well. Y minus 4 is equal to absolute value of x plus 5. Now again, get rid of this by adding 4 to both sides. So this is the V graph because it's still absolute value. But there are two moves. This is input, so it's 5 to the left. And this is output, so it's 4 up. So 5 to the left, 4 up. And that's your new starting point. Then you use the same pattern as a V graph would normally do. Over 1, up 1, both ways. Over 2, up 2, both ways. There's your new V graph. Does that make sense? Alrighty, 7e, y minus 1, oh sorry, y plus 1 equals, was it negative absolute value? Yeah. Negative absolute value of x. It's going to be a V graph. First of all, get rid of the 1 by subtracting. I see two changes. They're going to move it down 1. And this is a flip. And it's an output flip. It's not inside the function. It's outside the function. So it's going to be a flip upside down. So here's what it looks like. The original graph, again, starts at the origin and goes up. Over 1, up 1, over 2, up 2. Here, move it down 1. There's your new starting point. And then, this means it's upside down. So instead of over 1, up 1, it's over 1, down 1. Over 2, down 2. Okay. Does that make sense? There's your new graph. There's number 7. As long as we're actually going through these, any questions on 5 or 7? Does that make sense? All right. Looking at number 9, A and B. Number 9A, they gave you the graph in example 9. Especially if you missed this, you might be paying attention. On page 144, they give you example number 9. Y equals 2 to the x power. They just gave you the graph of that. And then they want you to modify it, A and B. So to, is everybody okay with this one? The mountain graph? I need to erase. So number 9, here's the basic graph. This is like, say, a brand new parent graph that I didn't give you. You don't really need this for the test yet. There are lots and lots of parent graphs, so I'm not going to do all hundreds and hundreds of them. It looks like this. If you want to graph this, use a table. There's, whoops, x, y. I'm going to do like -3, -2, -1, 0, 1, 2, 3. What does it look like? How do you do 2 to the -3? What's 2 to the negative? Let's go through the list. Nate, help me out. What's 2 to the 3rd? That's 3 to the... Yeah. What's 2 squared? 4. What's 2 to the 1st? 2. What's 2 to the 0? Not quite. Look at the pattern. What's going on? How do you go from 8 to 4 and from 4 to 2? What do they do? Yeah, it's 1. Anything to the 0 power is 1. The only exception, remember the only exception to that rule? What's the one? Yeah. 0 to the 0 power, right. 0 to the 0 power is undefined. Nobody knows what it equals. I'll explain that in a second if you've forgotten. But can somebody tell me 2 to the -1? You can actually just follow the pattern. What would it be? Yeah. What is it doing every single step? Right, do it again. Yes, exactly. What's 2 to the negative 2? 1/4. One more time. 1/8. And a shortcut, this is really 1 over 2 to the 3rd. So if I give you like 2 to the 10th, I just memorized this. This is 1024. You do not have to memorize this, by the way. Can anybody tell me 2 to the negative 10th? Very close. Here's a hint. 2 to the negative 3 is 1 over 2 to the 3rd. So what's 2 to the negative 10? 1 over 2 to the 10th, which is, I would accept that. Or 1 over what? 1024. Does that make sense? Any negative power dumps your answer in the basement and leaves a 1 on top. So we do this here. 2 to the power of negative 3 is 1 over 8. And this is 1 over 4, 1 over 2, 1, 2, 4, 8. Now you just graph these. It's a little weird to graph. 3 comma, negative 3 comma 1/8. Here. Negative 2 comma 1/4, which is kind of here. Negative 1 comma 1/2. 0 comma 1. 1 comma 2. 2 comma 4. 3 comma 8. Looks like this. It's going to torpedo up, and it's actually going to flatten off here. Does anybody recognize what sort of object seems to be running along the x-axis? Yeah, that's an asymptote. It's called a horizontal asymptote, but it's an asymptote. It's getting closer and closer and closer, but not touching. That's asymptote behavior. So, here's the graph. Look at problem 9a. 2 to the power of negative x. Now here's your parent function, remember. 2 to the power of x. Can anybody tell me what in the world they did? Did they move, resize, or flip? That's a flip. Is that input or output? That's input. If you notice, this is the input zone. It's very weird, but 2 to the power of whatever, the whatever is where the input is. 2 is not part of the input, it's the function itself. So if you have 2 to the x minus 1, the minus 1 is output. 2 to the power of x minus 1, that's input. So this is an input, and it's an input flip. What does that mean? Like, yeah, it's going to flip left to right, which means 2 to the negative x, so it flips side to side. This point here is going to reflect here. This is going to reflect here. This here. This stays put. This goes here, here, here. Here's the new graph. I didn't draw that very well over here. It's supposed to look like this. But you see visually what happened? It flipped like this. Again, it could be the weirdest function in the world. It could be the weirdest non-function in the world. But you can always flip it by switching all the x values to negative. If it's already negative, make it positive. So I pretty much just made it 3 comma 1/8, 2 comma 1/4, 1 comma 1/2. 0 stays put. Change this to negative. Change this to negative, negative. Make sense? Think you do that. And then I just had to do 9b, correct? 9b was asking for 2 to the power of x minus 1. Can somebody tell me what that means? Move, resize, or flip? Mary, take this one. How does this compare to that? Move. Input or output? Input. So where's it going to move? 1 to the right. It moves to the right 1. So you take the original graph and move it 1 space to the right. This will be here, here, here. Every single original dot is going to move 1 space to the right. So here's your new graph. Does that make sense? Again, once you get the original dots, the rest of it is just move them or resize them or flip them. That'll do that. Number 11. x squared plus y squared. This was tricky. We have associated x with input and y with output. But this is the first time where they didn't write it as a function. Everybody recognize the shape, by the way? I mean, they drew a graph of it, so I suppose it gave it away. What is it? Yeah, it's a circle. And we went through one of those. We're actually going to have an entire chapter on those soon. So we've got x squared plus y squared equals, is it equal to 1 or equal to 9 or something? 9. What happens, what's the input and what's the output? If you did not get this one, don't beat yourself up. This is tricky. But let me show you. It's easy to do once you know the trick. Trying to figure it out from the get-go is sometimes royally hard. Can everybody see just visually on the graph, what did they do? Like, did they move it, resize it, flip it? Yeah, they moved it. How many different ways? Up 4 and over 8. Over which way?
Right.
Yeah, so it moves 8, moves to the right 8, and then what?
Up 4.
Up 4. Yeah. We would expect to add 4 to the output, and how do you move something to the right 8 spaces? Tuning in. Go.
Take that. Well, subtract from the x then.
Yeah, subtract from the input. The only problem is I don't know where the input and output are, because a function input is easy. It's in the function. Output is outside the function. This is not a function at all. How do you do it? It's actually easier than you think, although very surprising. Both of these are treated as input. There is no output. When you have x and y glommed together on one side, you've lost functionhood, and so both of them are input. If both are input, then they're both going to do the opposite of what you expect. You want to take a stabbing guess of what I do instead of x. Same. What would I put here to move it to the right 8?
X minus 8.
Yes. Can anybody take an educated guess if this is input? It's got to be the opposite of what you expect of moving it up 4. Okay, what do you think?
Minus 4.
Yes, indeed. Y minus 4. That's your equation. And that's the answer, number 11. Does that make sense? It was weird, and it was a brain teaser. It was sort of a teaser for, we're actually going to do a bit of a jump after this chapter. We're jumping to chapter 10, which is, I'll tell you later, but it's interesting. Very, very. In both senses of the word. It's interesting in the sense of fascinating, and interesting in the sense of, you'll find out. It can be intense. And then last question, any repeats, sorry, on the homework? Okay, questions? Any of those you want to see dissected that we haven't already? Okay, as a summary, if you know how to move, resize, flip, and modify the equations, you're in good shape. That's pretty much all of this section and the last 2 sections we're doing. And if you can recognize if something's symmetric with the reflections. In other words, if you reflect it and nothing happens. Yeah. Is that okay, so far? So there's a quick summary in the last 3 of our sections. Everybody good? All right. Let me talk just a wee bit about periodic graphs, because I felt a little guilty giving you problems 1, 2, 3, and 4, and then giving you absolutely no idea what the problems were asking. It takes 5 minutes, and after chapter 10, we're going to be, pretty much until the end of the year, we're going to be doing trigonometry. If you remember that from second year algebra, it's coming back on steroids. So it's not going to be that bad, trust me. When we get there, it's actually pretty easy. Let's try this. Example. Go ahead and take out your notes, please. Do me a favor. Go from -4 to +8 on the x-axis. And go up 2, down 2. And then as soon as you can, try this. Let's assume that this thing is periodic. That means that it cycles. The word period implies something that comes over again and again and again, like fourth period. It happens again and again and again. After third period, before fifth period. You know where it is and what to expect, more or less. Periodic means that the graph or the function is going to keep repeating. It's going to get the same values over and over and over in a pattern. Just for giggles, let's call this f of x. And it keeps going. It'll go like this and start going down like this. If it's periodic, there should be a way to predict what's about to happen. It might be easy, it might be hard, but at least in theory, we should be able to predict it. Questions? Here are the values of the graph. I want to start at -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Can somebody tell me the values? If you plug in a -4, basically it's f of x equals some weird formula. I haven't the foggiest idea what formula would cause this, by the way. I kind of sort of have an idea, but it's really super hard. And it's much easier just to look at the graph. So f of x equals, I have no clue. But we can get the answers anyway. You might be asking, well, how am I supposed to get the answers if I can't plug anything in? You tell me. Can anybody tell me another name for f of x? Y. F of x can be replaced with y. Y can be replaced with f of x. So, Rainey, help me out with this one. -4, if you go to x equals -4, what's the value of y? Exactly. That's all you do. The graph will tell you, it'll give it to you on a silver platter. Give me 2 of them. What's -3? Say again, I'm sorry? 1. Another 1, correct. Chili, take the next 2. What's -2?
0.
0. And -1?
-1.
Good. Becca, take the next 2. What's 0? Yeah, and 1? Come on. If x is 1, what's the value of y?
Oh, -2.
Yeah, it's still -2. Does that make sense? Okay, I'm going to take over. And x is 2.
-1.
Good. And 3? 0. Okay, right Claire, take the next 2. If x is 4, 1, and 5? 1. Take 6, 7, 8. They're cheap. 0? Good. Do you see what's happening? It's 1, 1, 0, -1, -2, -2, -1, but eventually we get a 1, 1 again. This is a duplicate. If you kept going, the graph did not keep going, by the way. Can anybody tell me how long it takes to repeat? when does it start giving the same answers in the same pattern again? Like, how many spaces do you have to go before it starts repeating? Go. It looks like it might be 8. Like I know from the start of the plateau to the start of the plateau, it's 8. From the bottom of the plateau, beginning to the bottom of the plateau, that's also 8 spaces. So yeah, that's a good bet. By the way, that is called the period. How long it takes to repeat is 8 spaces. So this is a periodic graph where the period is 8. Does that make sense? That's actually one of the questions the homework was asking you, and I completely spazzed on teaching you what it was. My bad. Rich will slap on you again. So, can somebody predict the next 8 numbers? Okay, help me out. What would you expect to see happen here? Exactly. Why would you say that? Yeah, because if you notice, 8 spaces ago, we hit our first -2, and that was immediately followed by a duplicate. Keep going, as long as that. Uh-huh. Uh-huh. Yes. -2. Let me see what's going on. Every 8, it's going to repeat. That's our key for predicting things in the future. Now, the easiest one to start predicting from is 0. I'm going to say this, f of 0 is -2. Does everybody see why? It just plug in a 0 and you get -2. This is just code for that. F of 8 is what? -2. What's f of 16? Keep going. Can you make a wild guess of f of 24? How do you get that so fast? It's a multiple of 8. You increase this by 8 and you start it over. So all the multiples of 8 seem to be predictable. What's f of 800? Yeah. What's f of 1,000? Does 8 go into 1,000, by the way? I mean, evenly, without a decimal. Old mental math people. Yes, it does. 125 times. So this is a multiple. This is 125 times 8. So, hey, what do you think the answer is? You got it. That's how the book did it. If you find the period, then count. 0 is the best one to count from. You can't always count from 0, though. Let's see if you can do this. What's f of 3? Josh? 0. We knew that from our chart. Now, that's not a multiple of 8. Do we go multiples of 3? Unfortunately, no. What's f of 11?
0.
I didn't put it on the chart, but what's f of 19?
Also 0.
Explain. How come? What's happening here? Yeah.
I'm just going by 8.
You're going up by 8. Every 8, it'll repeat itself. It's annoying to start from 3, because if you start from 0, you can just do multiples of 8. Almost everybody can do that in their head. This, it's a multiple of 8 plus 3. It's like that. It's going to be 0. Now, the question is, what's f of 1003? Give me a tell me. Is there anything? What do you think? It's 0. Because all of these are multiples of 8 with 3 added. All of them will have the same value. What's look back at the book. That problem number 1, 2, 3, 4, let's take a look at those again. They might be a little more comprehensible now. Can somebody tell me on number 1, what is the period of that graph? How long does it take to repeat? Josh, take this one. Looks like it's 6. The easiest way, like you can go from anywhere to anywhere as long as it's a duplicate. I just went from the bottom valley to the bottom valley. That seems easy. The bottom valley, it went from like -2 to +4. Did we see that? So it looks like the period is 6. You could also go from the first mountaintop to the first mountaintop, and that's 6 spaces away. So the period is 6. So every 6 spaces, it'll repeat. So tell me, in that particular picture, Sam, take this one. Number 1, what is f of 0? 1, because that's a height of 1. So what's f of 6? 1. What's f of 12? What's f of 600? How are you getting that? They're all multiples of 6. Is 1,000 a multiple of 6? Anybody? No. They asked for f of 1,000. How are you supposed to do that? What did you say? Well, can you make it the closest multiple of 6 to 1,000 without going over? There's a little bit of a mental teaser problem. What's the biggest multiple of 6 you can get without going over 1,000? Well, let's start it. Would 900 work? Is that a multiple of 6? Oh, math people. Yeah. Yes, 900 is a multiple of 6. How about 960? Okay. Yes. How about 990? Is that a multiple of 6? How about 996? We just got the biggest multiple of 6. 996. Question. Oh, math people. Let me write this on the board. 996. How far away from 1,000 is that? First of all, that's the semi-dumb question. Next. 4. We're 4 spaces shy of 1,000. What did you say the value of f of 0 was again? 1. So f of 996 should be 1. Go 4 steps beyond on the picture. You said it was the same answer as f of 0, right? F of 996 should be the same answer as f of 0 because it repeats every 6. So I want you to go up 4 spaces. In other words, I want to find, sorry, I'm messing this up. What's f of 4? Look on the graph, you should be able to see it. What is f of 4? There we go. -1, I guarantee you. F of 1,000 is -1 as well. And it is. Makes sense. Any other questions? That's kind of how they did that. So find the period, see how many periods you can go before you get close to 1,000. If you hit 1,000 exactly, rejoice and be glad. But otherwise, tweak it a little bit. This, again, I'm not going to test you on this chapter, or even necessarily next chapter. The following chapter will come up. We'll have some formulas where you can guarantee how to find the answer. You don't have to just muscle through it, but this is good mental math. Okay. Any other questions on the whole thing? Going once. Going twice. It's better. Thrice. All right. Check out your notes, please. I want to talk a wee bit more about inverse functions. How do you get inverse functions? Well, how do you get inverses at all? Can somebody tell me the one step you need to do to get an inverse of anything? There's one, how do you get an inverse? It's one of the reflections, actually. Got it? Okay. Back up. Switch X and Y. Which reflection is that, by the way? Over the line Y equals X. To get an inverse of anything, you take X and Y and trade places. Hopefully that kind of makes sense. Because an inverse is the backward version of the original problem. So switching X and Y will make it go backwards. Input with output, if you trade places, that's backwards. So, find the inverse of x cubed y plus xy squared all over 3x plus 2y equals 5. God help you if you want to try and graph that thing. I have a computer program that can graph that, and it's, wow. It kind of spirals and like overlaps on itself and smears part of the graph. It's really pretty cool looking, but trying to do this by hand, you've heard. But the inverse is not that hard. How do you do it? Go.
Just switch things.
Do it.
So y cubed times x plus y times x squared all over 3y plus 2x
Equals 5. You don't change the 5. Now, what I'd probably do to neaten it up, because mathematicians like alphabetical order, it would be x y cubed plus x squared y all over 2x plus 3y equals 5. But that's it. That's all you have to do to get an inverse. Does that make sense? So getting the inverse is relatively easy. A little bit of notation. When you're dealing with inverses, there's two, I told you this yesterday, there's the difference between an inverse versus an inverse function. Here's what they're talking about. There's an inverse, you can do with anything. An inverse function has to be a function when you're done. And they actually have special notation for it. It's very easy, but that means it's very easy to miss. Here's what an inverse looks like. Here's the notation for an inverse function. Difference is capital letter. They reserve a capital letter for inverse functions. Oops, there's a bad circle. They use a capital letter. Has anybody seen this in the past? I think we played with it last year, didn't we? A little bit. I think we even graphed a few of those, sine of x, like it was going up, down, up, down, up, down. There is such a thing as an inverse sine function. Put a little -1 here. This is an inverse sine. This, I don't know why I did that backwards, is an inverse sine function. See the difference? I'm going to give you a quick demo. What would they look like graph-wise? I think we got those. What's the difference between an inverse and an inverse function? Again, you might or might not remember this from last year. Y equals sine of x. We studied things, actually last year we did very briefly study amplitude, period, horizontal shift, that sort of things. When they're talking about periodic functions, that's exactly what they're talking about. A period is how long it takes to repeat. We were talking about quarter periods, which were 1/4 of the period, etc. Y equals sine of x, just for, again, we're going to go over this in 2 chapters from now. But it looks like this. Pi over 2, pi, 3 pi over 2, 2 pi. It goes up to 1, down to -1, Sine starts at the baseline and goes up to the max, then back to the base, then to the minimum, then to the base, and then it keeps going. And it's round, smooth, curvy, not sharp, pointy, teethy. So don't just go ziggy zaggy and make a bunch of sharp teeth. That's not how it works. And it keeps going. That jar any memories from last year? Out of curiosity. Okay. So what does this look like? This is the inverse sine. We actually know how to do this now. Last year we probably didn't. And I made my graph very strange looking. Any idea why? How do you get an inverse? Oh, people who are plotting through courageously through chapter 4. Yeah. You flip all the x's and y's. Can anybody give me the, well, this is a stupid question, but coordinates. 0, 0, flip them. Yeah, exactly. Coordinates, what comma what? Pi over 2 comma 1. Give me the inverse. Don't work too hard. 1 comma pi over 2. Nate, take over. Coordinates. Pi comma 0. Give me the inverse. 0 comma pi. Josh, give me the next one. Coordinates. Yeah, comma, sorry. There. 3 pi over 2 comma negative 1. Give me the inverse. Negative 1 comma 3 pi over 2. Mary Claire, give me the next one. Coordinates. 2 pi comma 0. What's the inverse? 0 comma 2 pi. It goes like this. And we'll keep going. See how that works? We now have the power to graph anything that has an inverse. Question. Is that inverse a function? Okay. No. Why do you say no? It does not pass the vertical line test. Correct. This fails the vertical line test miserably. It hits an infinite number of times, which is pathetic. Is there a way we could have known that ahead of time? That the inverse was going to flop?
It's not capital.
First of all, it's not capital, definitely. That's actually a very good point, yeah.
Use the horizontal line test in the first one.
The original graph didn't pass the horizontal line test. So we knew that its inverse wasn't going to be a function. Now, here comes the surprise. Picture yourself walking down a dark alley. Why? Because you're feeling reckless. And in a very mathematically rough part of town, you come upon a bunch of mathematical hoodlums who say, hey, nice coat. Nice to see you in our territory. So, you think you know mathematics? Well, my boys and I like inverse, but they like inverse functions. So I don't even know what accent this is. I'm just speaking. So we want to just see if you can give us, just like a hostess gift for coming into our place, the inverse function. Yeah, and he says, oh no. This is not a function. What are you trying to do? I want an inverse function. So that, you say you don't have an inverse function. Oh, that's so sad. Make one anyway. My boys and I will wait. With our various clubs and barbed wire and other instruments of scaring people. Is there a way to turn this into, by the way, this keeps going. This is like negative pi over 2. This is like negative pi. So we're in serious trouble here. The thing keeps going forever. How? this is, how do I say this metaphor without getting really, really gross? This is, I had a metaphor for it, but I said, oh, that's too sicky for me. So I'm going to try and change it on the spot. I want you to, I was going to say amputate, but in this time where people were using violence, that's too darky. So you're holding up this like piece of artwork, but it's not a function. And they say, we're waiting for you to make it a function. We want the function, and we'd like it in 45 seconds or less, which, by the way, is how much time we have left. So, watch this. What if I say, you know, guys, we need a function real fast. I know you're really, really attached to this, but would you mind if I like cut some of this off? Snip, snip. Is that a function? If I took wire cutters and guys, we're gonna die here, I'm sorry. I know it's your artwork, I know it's your baby, but I'm sorry. Not little baby, but wow. No, this is being filmed too, isn't it? I'm kidding. All right, but do you see that little snippet is a function? That's exactly what the inverse sine function is. I'll explain more on it later when we get into the 2 chapters from now. But that's a function. You can make something a function by clipping it. Don't get used to this. No homework for tonight. Please stand. People watching at home, yes, you're welcome. In the name of the Father, of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Maybe you can forgive me for all the gross metaphors that way. See y'all later. See y'all later too, of course.